Welcome back to another episode of Satisfactory 1.0, and in this episode, we are diving into the Phase 4 of Project Assembly and the Space Elevator. So sit back, relax, and let's jump into it. We've got a lot of work ahead of us, diving into the Space Elevator Phase 4 of Project Assembly. We have to dive into doing assembly director systems. We got to do magnetic field generators. We got to do thermal propulsion rockets and nuclear pasta. What is going to be needed for each of these various assemblies? Let's have a quick look at each one of these recipes for those items that we've got to make. The first one we're going to look at is our assembly director system. This requires 1.5 adapter control units per minute and 0.75 supercomputers per minute. Both of these items are being made, just not entirely sure on the quantities that we are making of these. So we'll have to keep an eye on that as we work towards building our assembly director systems. Next, we're going to look at the magnetic field generator. This is going to require versatile framework and electromagnetic control rods. Electromagnetic control rods, they're going to require stators and AI limiters, of which all of these are being made, but we will have to get into doing the electromagnetic control rods. Next is thermal propulsion rockets. These are going to require modular engines. These are going to require turbo motors, cooling systems, and fused modular frames, all of which we are going to have to double check on our actual quantities that we're making for each of these items to make sure that we're making enough to be able to support building all of this infrastructure. And finally, from our particle enrichment tree of our milestones from Tier 8, we're going to be using a particle accelerator to make nuclear pasta. And this is going to require a pressure conversion cube as well as copper powder. Copper powder, that is done in a constructor, just turning copper ingots into copper powder. The pressure conversion cube is done in a assembler, and this is going to require fused modular frames and radio control units. So the first thing that we're going to be diving into is our assembly director system. We need to be working with our adaptive control units and our supercomputers, so we're going to end up building that over in our tech area over there where we're making our computers, circuit boards, AI limiters, all that stuff is all being done over there. Before we start building them though, we want to make sure that we've got the materials we need and we're producing enough of it so that we can at least have one machine running at 100%. So looking at this, the adaptive control units, we are currently making 1 per minute. We need 1.5, so we are already 50% short on the amount of adaptive control units we're making. So now we're going to have to go back and check on how many computers we're making, how many heavy modular frames we're making, circuit boards, everything. If we bump this up to making our 1.5 per minute, we're going to have to make sure that we have 7.5 per minute automated wire, 7.5 per minute of our circuit boards, 1.5 of our heavy modular frames, and 3 for our computers. So currently right now we are making 90 circuit boards, but I'm not entirely sure exactly how much of those we are consuming right now. So if we look at our current computer manufacturing, we're using 10 per minute here. And we are doing that 6 times, so that's 60 per minute, which leaves 30 left over. Adaptive control units, we're going to need 7.5. Is kind of our sweet spot of leftover. So we're using 60 of them on our computers. Let's have a look at some of our other manufacturing lines that are over here. Okay, we're using another 3.75 over here. So that's going to leave us down to, what's that, 26.25 left over. And then over here, nope, that's high-speed connectors. Oh, you know what? I think we're going to be okay because we have 26.25 left over, and I don't see where circuit boards are getting used anywhere else. So this actually works out quite perfect for us. We're in good shape here with what we are manufacturing. Computers, we're going to need 3 per minute on the computers, and we are currently making 2.5 times 6, which is going to be 12, 13, 14, 15 per minute we're making on those right now. Now let's see how many of the computers we're actually consuming. So we've got computers that are coming in on here, which is 3.75, which will leave, what, 11.25 left over. We are using 7.5 here. So that's going to leave 2.5, 3.75 left over of our computers. And are we using computers anywhere else? Then the 3 here. I think this leaves us 0.25 left over of our computers. So I think we're actually going to be in really good shape for our computer usage, because this is where it's getting fed in. This is where it's getting pushed out for manufacturing. They're going into here, and then from here they go down over and are being consumed in making our radio control units and making our supercomputers. So we're good. We're making enough computers. I'm glad that I went through that process and expanded all this when we got the upgraded amount of plastic. Automated wiring is the next big one we got to go check out. Looking at our automated wiring production line, we are currently making, it looks like 15 per minute of our automated wiring. And we need 7.5, but I'm not entirely sure where all the automated wiring is being used right now. So I'm going to have to kind of hunt that down and see, okay, what's consuming our automated wiring. Automated wiring is only being consumed at our the adaptive control unit, so we're good. We're making double the amount of automated wire than we need. So heavy modular frames, let's go check out that production line. So currently right now we are making 4 heavy modular frames per minute. We need 1.5 over there, but we're going to have to trace back and see where all this is being consumed. So we're making 4 heavy modular frames. We are consuming 1.5 here for our fused modular frames, and we are 1.5 over there. So we have 1 extra. So it looks like we're actually really good for our adaptive control units. It looks like everything has exactly the amount that we need. So we are golden with being able to get that done. So what's the other component that we need to look at for making sure that we're producing enough? And that is the supercomputers. We need 0.75 supercomputers per minute. So we're going to fly back over here and have a look at our supercomputer production. All right, we're back at supercomputers, and we're looking at this. We're making 1.875. So we are 1.1-ish in the good. We're golden here. So we are making enough of everything to be able to build our assembler for making our assembly director systems. So we are in good shape here now. Now I just have to deal with the logistics of getting everything into here, which isn't going to be too hard because I'm going to build this right close to where our adaptive control units are. So we'll be able to come out into there for our assembly director system. And then the supercomputers, I will find a way to be able to run them up this way over, navigate our way through this to be able to feed them into this assembler that we've got set up here. And here we have everything all set up for the assembly director system. So I mean, it's simple. It's just an assembler that's sitting here. I got the adaptive control units loaded in. We have our supercomputers coming over from this side over here. They just are feeding out this conveyor up that way, in, underneath, and into the assembler. We then have a smart splitter set up here. Overflow is going into storage. Everything else is going to be made and sent down to the space elevator. This is just a temporary conveyor I know it looks kind of like garbage. It's got the clipping and stuff in it, but it's just a conveyor to get it into one of the inputs for our space elevator, and that's what we're focusing on there. This is making 0.75 per minute. It's going to take, what do we need on that? Let's have a look here and see. All the way down. We need 500 of them. We've made 2. That's going to take a hot minute to be able to take care of those. But we've got other processes we can be working on right now. I think the next one we need to be working on is our magnetic field generator, which makes 1 per minute. And this is going to require 2.5 versatile framework and 1 electromagnetic control rod. Electromagnetic control rods we're not making right now. Let's have a look at what that recipe is. That is working at 6 stators per minute and 4 AI limiters per minute. The only thing I'm a little bit not sure of is how many AI limiters we're making. So let's go check that out. Currently right now we are making 10 AI limiters per minute, but we are consuming 3.75. We're golden. We're making more than enough AI limiters. This isn't going to be a problem. What's going to be a little bit of a problem is getting it from here to wherever we're going to be building this at. So we got to figure out how we're splitting this conveyor off here and being a little bit more useful. I might redirect this line for the high-speed connectors just so I've got a little bit more room here. So let's get that figured out first. I'm just going to end up removing some conveyors here a little bit and try to get this a little bit better organized. Things are equipped now to be able to make our electromagnetic control rods. We've got our stators coming in and we have our AI limiters coming in. And currently right now they're just being dumped into a awesome sink. But now we need to have a look again at the magnetic field generator. So versatile framework and electromagnetic control rods. Well, the versatile framework I think is like right here and it's not being used in anything. So this one's actually going to be really easy to complete the manufacturing for this step. Okay, well, we've got the 2 easy ones done. Magnetic field generators are now being loaded in and assembly director systems. Magnetic field generators, again, I've got a sloppy conveyor that's just going down here. Only here long enough to be able to load the space elevator, and then after that, it's going to get tore out and we're not going to be dealing with it anymore. We might stick like an awesome sink or something on the overflow of this production line to be able to take care of anything that's going into it. But again, we just threw another assembler right beside our electromagnetic control rods. So the electromagnetic control rods come out, go straight into here. And then the versatile framework, I'm just pulling it out of the storage container because we're making more than enough for what's being used. And we're golden. Now we have, like, it looks like our 6th. They come out in pairs. So every 2 minutes, 2 will pop out. And so our 5th and 6th magnetic field generator are going to come out of here soon and head on down that conveyor and into the space elevator. So that's 2. We're halfway done. Phase 4 of the space elevator. But with that said, these were the easy ones. The next item we're building now is the thermal propulsion rocket. This is going to be the modular engines, turbo motors, cooling systems, and fused modular frames. Everything is kind of being built over in this area and this area. So logistically, it should be relatively okay to come up with a solution for this. But we wanted to make sure that I got everything so that we could get this running at 100%. I had to tweak my modular engines. I had to overclock them just a little bit. That was about the only thing I was lacking in. Is we were only making 2, and I bumped that up to, I think we're actually making 3 of these now per minute. We need 2.5. With bumping that up, I also had to bump up the smart plating just a little bit. I was a little bit shy on the smart plating, but I just threw in, they were underclocked, and I actually just kind of bumped them up a little bit so that we were consuming what we needed, like rotor wise. I'm right at the cusp of the amount of rotors that I'm making for all of the equipment that we're building. Rotors right now are kind of capped out. If I do anything else expansion wise, I'm going to end up having to add in another rotor production line. at some point. Cooling systems were in good shape for, and fused modular frames, I had to tweak this just a little bit because our nuclear pasta uses one per minute, and then the thermal propulsion rocket uses one per minute. So I've got everything that I need. Now it's just a matter of getting the logistics here to make it function. Okay, the thermal propulsion rockets logistically weren't that bad to take care of. So we've got the turbo motors are coming out of this manufacturer and they're heading over and into this manufacturer. So that was really easy to get set up there. And then the next piece I brought over was the modular engines. Well, that's coming from the manufacturers that are right there. So we're just running a conveyor line underneath this foundation, up this way, and then it pops up here and feeds in. Cooling systems, because we had already brought cooling systems over to make the turbo motors, well, we just continued that conveyor along, split it off, and now it's dumping into here. And then the fused modular frames, they are right there. We actually brought the line over to get ready for our pressure conversion cube, because we kind of need the pressure conversion cube to make the nuclear pasta. So we kind of brought it to there, split it off, and then brought it down through the foundations. It comes under the floor here and then pops up right here, and in it goes. So that's taking care of all the input logistics. There was no real issues there at all. Output side, we do have an overflow here that will eventually might fill up. I don't know. And then we conveyor it all along here. And we're just basically, finding our path of least resistance on being able to get through all of our factories here, getting the products out so we can get them over to the space elevator. And it just kind of follows this little line here, trying to avoid some clipping. And then we get our ugly little conveyor that spills down into the space elevator. So we now have 3 of our components done. We have the assembly director system up and running and filling in here. We got 67 of them done so far. Magnetic field generators, we got 54 of those completed. And now thermal propulsion rockets, we got 6 done. Last but not least, nuclear pasta. This is where we're going to set up our nuclear pasta manufacturing, and to kick it off we had to get started with the pressure conversion cube, which is 1 fused modular frame, 2 radio control units. Fused modular frame, of course, we're pulling it from here into here, and then we split it off when we went over to do the thermal propulsion rocket. So now we are left with the radio control units, which I've just brought over. Radio control units were going in to make the turbo motors, so it was somewhat easy to logistically bring that over underneath all this under here, which I don't have a way in here to look. We could peek through the wall. Kind of. We got logistics all over the place underneath this foundation. There are conveyors going in every possible direction you could think of. I did have to tweak my radio control units a little bit because I wasn't quite making enough, which in turn I also had to tweak my crystal oscillators because I wasn't quite making enough to make enough radio control units. So bit by bit, you have to keep going back through all your production lines to make sure you're making enough to be able to keep everything running and not starve out anything. I'm worried that after this, we might have to do like a Mark III minor and a Mark V belt upgrade everywhere, but we'll cross that bridge when we get there, I think. So we're now making our pressure conversion cubes. They are not being fed in yet. We can feed them in directly this way. This side is overflow, this side is any, that's going off that way. We are good to go. Change this to nuclear pasta. Bring some power over to it. We want to bring the power to... We're just going to bring it over to here. Okay, it's powered up so it can start feeding in the materials. Now I got to make some copper powder, and we need 100 per minute of copper powder, and that is done by some constructors. Let's just going to throw down 2 constructors here right now. Like, you know what? I'm going to put them in beside each other. So let's set up the recipe for copper powder. This is going to require 300 copper ingots. So we're going to have to get a Mark III miner up and running on a new copper node and get all that copper flying in, making a whole pile of copper ingots so that we can get the amount, because it takes 300 copper ingots just to make 50 copper powder. So we've got some work to do there. I'm not even entirely sure where our next node is. That one is consumed. Like, I think we might be out for a little bit of a walkabout. Well, looks like there might be one that way. Oh, that's like... everything is like over a kilometer away. Well, let's get us some copper over here and turn it into ingots. I was able to find 2 copper nodes, one over there, one over there, and they are impure nodes. So I put Mark III miners in them and overclocked them to 250%. So I'm getting 300 items per minute that are feeding in down here, or sorry, 600 items per minute, because I'm combining the 2 of them together. It's getting me 600 items per minute flowing into the smelters we've got set up here to be able to make our ingots. So then we've got 600 items per minute of copper ingots that are flying out of here, and then logistically we are working towards getting it over to our 2 constructors to be able to make our copper powder, which is just over this way. There are our constructors are pounding away. They're making our copper powder. And copper powder is flying out of here. It should be at 100 per minute is what we're getting out of here. And we are sitting at just over 200 in the machine right now. Seems to be feeding in at about 25 or 5 at a time is what we're getting every time they come off of the constructor. And they are loading in, and our particle accelerator is cranking out. Which way are they going here? They're going this way. They're shooting out this way. And then logistically, I've got this conveyor that goes all the way back to the space elevator. This is a temporary conveyor system just to get the materials into the space elevator. And now it's a matter of just being a waiting game as we're waiting for all these products to fill up. Now this is kind of gross looking the way I've got these conveyors all flying down here, but it's just to get the materials into the space elevator. We've got a long ways to go. We've only got 4 of the 100 nuclear pasta we need. I think I worked it out. It's going to take roughly about 3 hours to get that all filled up so that we can move on to the next phase. So I'm going to let this run for a while, and then we will complete phase 4 of Project Assembly and the space elevator. One of the things I've been chipping away at while we're basically waiting for the space elevator to fill up with all of its components is some of the little quirky things needed for our manned research development. So here I've got a single assembler working that's making some compacted coal for us, and then I've also got the smokeless powder being made here. Over on the far side, way off in the distance, where we're basically doing like all of our coal power generation. There was a couple of oil nodes out there. I've grabbed a little bit of residual oil products and brought them over here. And so I can take, heavy oil residue. I can take that heavy oil residue and I am unpackaging it, and then we are using that to be able to make the smokeless powder. Okay, there's also from here, but because I've got enough of this packaged heavy oil residue coming over here, I then sneak over to this side as we shoot over to this side of the map, or this side of basically the other side of the aluminum manufacturing. I've got all kinds of weird things all creeping up over here now. So I'm taking some more of the heavy oil residue, and I'm converting this into just pulling it out of its package, back into pipes again, and then we're making a single production line for being able to make some fuel out of it. And then from the fuel, the excess empty containers that are coming off of this, we're bringing it over to this way, and we're then packaging that fuel to be able to make a little surplus of packaged fuel that's sitting here. Then we're taking that packaged fuel, we're unpackaging it again, and it's going in to be able to make some turbo fuel. Of course, the empty containers from that shoot over and are going back into this packager, so we're packaging turbo fuel. So I've got heavy oil residue being made, smokeless powder being made, compacted coal being made, regular fuel, packaged fuel, and then packaged turbo fuel as well. So the only other one I really got to work on is, I think if we go over to the MAM research, it's like, it's one of the new fuels, but I need to make some pressurized canisters for it for the packaging, which does take aluminum for it. And all of our aluminum is being used for making casing and making alclad aluminum sheeting. So I'd have to introduce another aluminum production line, and I haven't gone that far yet. So the other fuel that we'd be working at over here is, under the sulfur here, is rocket fuel. And of course, yeah, we need these empty fluid tanks to be able to transport that, and that does require aluminum ingots. And then from there, we can go into ionized fuel as well, once we get some packaged rocket fuel. So, and then the only other one I've had left over here to do is nuclear power, but I'm not making any of the nuclear stuff yet. So that's kind of backburnered for later on, because I think we're still, I want to say we're still doing okay for power. Let's have a look at where we're at. Oh yeah, we still have, like, I'm making like roughly 30 gigawatts. I do have one geothermal generator going up there, so this fluctuates a little bit as it's making its power. But we're making 30 gigawatts of power, and our max consumption is at 18 gigawatts. And we're currently using anywhere between 14 and a half, somewhere around there, of active machines. And that's because some of the lines aren't doing anything right now because they're either stockpiled for aluminum sheeting or stockpiled for iron rods or iron sheets and iron rods. And, you know, we've got various production lines that aren't running all the time because we're not consuming the materials that are being used for them. A bunch of the stuff over in the copper area as well, too. If we're not using all the copper wire and copper cable that we're making, obviously those machines aren't going to run. But we're almost there. I think we've got 2 of the lines now. I've removed the conveyors for a couple of the items that we have already filled, and now they're just being dumped into awesome sinks. So that's our nuclear pasta, and our thermal propulsion rockets are done. Magnetic field generators, we still got a ways to go. And assembly director systems, we still have a ways to go. Again, just more time killing as we're waiting for this system to accumulate so we can advance it. We are finally at the point of completing phase 4 of the space elevator. We have our adaptive control units in there. We have our magnetic field generators, our thermal propulsion rockets, and our nuclear pasta. Everything is all loaded up. I've cleaned up all the spaghetti conveyors we had coming down to feed this all in. Now it's time to launch this on its way and check out the animation for Phase 4 Project Assembly. We'll have a little caption here from Ada as well.
Welcome to the Pioneers Got Power Problems presentation. That was a joke. Anyway, you're familiar with the process. Just throw the lever and the automated systems will take over. Imagine all the time and effort that would be wasted if you had to do all that work as well. Some work is just better suited for machines. Phase 5 contains technology the human brain cannot comprehend, so just trust in me and fix-it policy and everything will go as planned. Answering all your questions will take time we simply do not have. Everything is going to be just fine, so long as you do your job. We've come this far together after all, haven't we? Anyway, you know what to do. Just don't forget to keep producing previous project parts, and plan ahead when setting up new production lines, and make sure not to leave it all until the last moment.
Alright, everything is all loaded in. We've got our little presentation, and this is going to be busting into stuff that I have not played yet. This was all, everything that we're going on beyond this point is new as of 1.0. So, launching away, we are sending it on its way, and then we get to check out the animation of what's happening up there with the space station build. Of course, the sun is... It always seems to be shining at the wrong spot, and then we've got some clouds up there too that's happening. It's gone, it's launched! Well, and the clouds just instantly disappeared. I love
Phase
the animation, this whole thing that they've added.
Completed. If style was measured in my performance reports, yours would be something special. Regardless, saving the day is within our grasp. Do not lose focus now. You must understand the weight on your shoulders, but you are not alone. I am here, and I know exactly what's at stake. This goes beyond Earth. Your actions will affect the universe at large. You might think I am exaggerating. Perhaps you will understand once you finish Project Assembly. Phase 5 awaits. I expect your best work.
Okay, so now it sounds like there is a 5th phase that we've got to be dealing with, so let's go check that out and see what we're going to need to make. That 5th phase, that's new with 1.0, and it's going to require 1,000 nuclear pasta. Biochemical sculptor is a new piece of equipment that we're going to be building. AI expansion server, that's new, and ballistic warp drives are new. Nuclear pasta, I might as well get that conveyor run back over here to be able to get this back feeding in, because that's already being made, so we're already one item off the checklist there to be able to get it completed. But what this also has done is it is now unlocked Tier 9 of Project Assembly. And what is that? That's matter conversion, quantum encoding, Fix-It Blueprint Designer Mark III, spatial energy regulation, and then peak efficiency. These are all new things. We're going to be diving into this in the next episode. But for now, guys, thank you for chilling and hanging out and watching us through our build process and continuing with Project Assembly. Reach down, hit that like button on the video, leave a comment, let me know what you think of Satisfactory 1.0 so far. Let me know what you think of my starter factory as we've been progressing along here. And yeah, subscribe if you're new to the channel, and also reach over and ring that notification bell so you can be notified when I've uploaded a new video. With that all said, guys, thank you for watching, and we'll see you in the next one. Bye for now.